Hi, this is another example of using energy methods to solve problems in a relatively simple way. Pause and read the question here. Okay, so we're going to use energy to solve this problem, so let's write down our basic equation for energy. So there's our energy equation, and now we notice that as the man is following down and tracing that path as he goes down on the rope swing, gravity alone governs this motion. We're ignoring any type of air resistance or anything. So the non-conservative work is 0, and this is a conservation mechanical energy problem. We've got a single person, and so we can rewrite the equation in terms of the kinetic energy and the potential energy for that individual person. So I plugged in for KE and PE, and here's what we're going to work with. And now I need to go ahead and find out what's going on at the initial and final spot. So let's go ahead and identify those. So the man starts here at the top, and this is where he releases the rope for path 1. So this is the final for path 1. All right, and as usual, we're going to go ahead and make a axis for the heights, a vertical axis, and this time I'm going to do it a little differently. Just to show you, I can choose my y to be 0 anywhere, so I'm going to call the initial height here 0 at the top. And down here at the bottom, I need to come up with my final height. 3.6, right? But it's below 0, so it's a negative 3.6 meters. Now finally, what are the speeds at the top and bottom? Well, he starts from rest. So at the top we've got a initial speed of 0, and then we're trying to figure out down here what is the final speed. Now I see that we have a couple of zeros in the speeds and height. So I like to plug those zeros in. First thing, initial speed 0, initial height 0. That means the entire left-hand side of the equation is 0. What do we have on the other side? Well, I can divide by the mass because both terms have mass. So let's multiply by 1 over the mass. We can cancel those out. Then we get v final squared over 2 plus g h final. And if we go ahead and do a little bit more math there to solve for v final, well, v final squared is going to be equal to, let's see, over 2 is going to be equal to negative g hf, right? And finally, multiply by 2 on both sides. Take the square root. And now we've got a value for v final. You might be wondering about that negative sign under the root. Can't have negatives, right? That's okay. Once we plug in the value for h final, it's negative. That's going to cancel it. So that's how we know we did this right. And when we plug this into our calculator, we get an answer. It comes out to 8.4 meters per second. And of course, this was path 1. We're also asked to compute this for path 2. Any thoughts what the answer is going to be? Well, really for path 2, all that changes is the position here. And in that case, look at the final height. It's still the same as before, right? The initial speed's still the same. The initial height's still the same. Because all three values, initial speed, initial height, and final height are the same, we're going to get the exact same answer when we solve for v final by the same method. So in this case, this is also the answer for path 2.